Hello everyone, welcome to the Epic Flight Academy. This is the Private Pilot Ground School and my name is Mike Thompson. To be successful in the Epic Flight Academy Private Pilot Ground School, there are three essential parts. The first part is reading and studying Epic's online private pilot course. These videos, like this one you're about to watch, is the second part, and we've made these videos to parallel that online content. The third critical piece to your success is reviewing all of this content with your flight instructor. Now, today, what are we going to talk about? Our lesson today is density altitude. Well, what do we mean by that? Well, there's two key words there. Altitude is our height in the Earth's atmosphere. We've talked about different types of altitude in the past. And density is exactly what it says it is. It refers to the density of the Earth's atmosphere at any given day or time or location. Now, there are three specific things that affect the density altitude. A good memory aid for that is the three H's. The three H's are high altitude, hot air temperature, and high humidity. Let's take a look at those in a little more detail in order. When we talk about high altitude, what do we mean? We mean in reference to our pressure altitude. Now, as you recall from earlier lessons, pressure altitude is defined as the aircraft's altitude in a standardized atmosphere. Meteorologists standardize the Earth's atmosphere as a reference point to measure the aircraft's performance. In the very near future, we'll start talking about aircraft performance and charts, and you'll see how we will reference pressure altitude. A standard atmosphere, as you recall, is 29.92 inches of mercury pressure at sea level at a temperature of 15 degrees Celsius, and then we have a standardized pressure drop of 1 inch per 1,000 feet and a standardized temperature lapse rate of 2 degrees Celsius per 1,000 feet. Now, that's a standardized reference. That does not mean that is necessarily the atmosphere's pressure and temperature at any given time or moment. So let's just stick with this pressure altitude. If we were in a standardized atmosphere and the pressure at the surface was 29.92 and the pressure decreased as we go up in altitude, the density of the atmosphere would be less due to that density decreasing. That means that your aircraft, when it's flying through this less dense air at a higher pressure altitude, would have less performance, because less dense air means less air molecules coming into the fuel-air system. So I get a less dense air charge into the cylinders. Less dense air crossing my propeller, so it is not performing as efficiently. Less dense air crossing my wings and other airfoils, so they are not performing as efficiently. And you can see in our diagram here, we're showing the aircraft's climb rate and angle and takeoff distance at sea level, and comparing that to the aircraft's climb angle, climb rate, and distance at a higher pressure altitude. Notice as we go up in pressure altitude, more distance and less climb rate and a more shallow angle. We're getting less performance because of less dense air because we're in a higher pressure altitude. Now, temperature also has an effect on performance. Temperature of the air affects the density of the air. If the air is cooler, the air is more dense. If the air is warmer, it is less dense. So again, you can see on our graphic right here, in cooler air, the air is more dense, the aircraft performs better, a shorter takeoff run, a higher climb rate, and a steeper climb angle. And in warmer air, a longer takeoff run because the air is less dense, a shallower climb angle, and a lower climb rate because the air is warmer. It is less dense. And then, thirdly, we talk about humidity. Now, humidity is water vapor suspended in the air. And there is a common misconception that because water is more dense than air, it stands to reason that humid air would be more dense, so my aircraft would get better performance. That is a misconception. So let's take that apart so we don't misunderstand it. Water vapor is not water. As you can see on this graphic, we've blown up a human hair and we see a typical raindrop of approximately 2 millimeters across. Now, 2 millimeters, it's about that. You can see that with your naked eye. In our graphic here, we're showing water vapor, and that is about 0.02 millimeters across. I can't even see that with my naked eye. That water vapor is suspended in the air. Well, how does that affect my performance? Let's see. We're going to have to go back to a little bit of high school chemistry. Oh no, not chemistry. I became a pilot because I was not interested in chemistry. Well, don't panic. We're just going to touch on the basics. The hydrogen molecule has an atomic weight of 1, nitrogen 7, oxygen 8. That's all we really need to remember from chemistry. Nitrogen is N2, so that's 2 nitrogens, so that's 7 plus 7, that's 14. Oxygen is 2 O's, so that's 8 plus 8, that's 16. Now, this is interesting. Remember that suspended water vapor that we were just talking about? Yeah, it's a 0.02 millimeters across, and I can't see it with my naked eye, but it's still water. Water is H2O. H is 1, and if there's 2 H's, that's 1 plus 1, that's 2. O is 8, there's only one of those, that's 8. What's 8 plus 2? 10. So, coming to our final diagram here, we see nitrogen with a mass of 14, oxygen with a mass of 16, and water vapor with a mass of 10. Now, that water vapor, which is lighter in its atomic mass, is displacing the air that my aircraft needs to perform. So humid air is actually less dense. Now, if you look at our graphic here, it's showing the aircraft in dry air with a shorter takeoff run, a steeper climb angle, and a higher climb rate. It's showing that same aircraft in moist air or humid air with a longer takeoff run, a shallower angle, and a lower climb rate. So that brings us around back to where we started with our 3 H's. If we have high altitude, and by that we mean a high pressure altitude, and high air temperature, and high humidity, all 3 of those cause the air to be less dense, and that will decrease my aircraft performance. So folks, when we think about density altitude, we think about the 3 H's. Remember, those 3 H's will affect our air density. Less density, poorer performance. So we need to carefully pre-plan our aircraft's predicted performance. And we'll be getting into that in the next couple of videos. Well, that's it for density altitude today, folks. Thanks for joining us. We'll see you next time.